Since the dawn of humanity, when man first lifted his eyes to the sky, the silence of the stars has stirred one of the most unsettling questions in history. If the universe is so vast, so full of galaxies and worlds, why is no one answering? This question, known as the whole Fermi Paradox, is not just a philosophical dilemma, but a scientific mystery that challenges our understanding of the cosmos and of life itself. Amid hundreds of billions of galaxies, each containing hundreds of billions of stars, the probability of other civilizations should be almost inevitable. And yet, all we hear is the echo of emptiness. No signal, no ship, no presence, only the cold cosmic silence. Physicist Enrico Fermi, while discussing this contradiction with his colleagues in the middle of the 20th century, summarized the mystery in a simple phrase: "Where is everybody?" It was a cry of perplexity before the apparent absence of evidence of other intelligences, despite the near infinite vastness of the universe. And from this provocation was born one of the most disturbing ideas in modern science, the Great Filter hypothesis. This theory suggests that somewhere between the emergence of life and the development of a civilization capable of conquering the stars, there exists an almost insurmountable barrier, a fatal stage that almost no one can surpass. The Great Filter proposes that the universe is not silent by chance, but because almost every civilization that tries to advance beyond a certain point simply does not survive. This barrier could occur at various stages: before life arises during its evolution, or when intelligence achieves enough technological power to destroy itself. In any of these scenarios, the result is the same: silence. It is a theory that forces us to look at humanity's future with a mixture of awe and fear. Because if the filter still lies ahead of us, then perhaps the destiny of all civilizations is the same: collapse. But there is also a more hopeful perspective. What if the Great Filter is already behind us? What if Earth itself is a cosmic exception, a statistical miracle that managed to overcome stages that wiped out countless worlds? In that case, the silence of the stars would not be a sign of tragedy, but of privilege. We might be the first, or among the very few, to cross the evolutionary abyss and achieve consciousness. Solitude, then, would be the price of existence. While our telescopes scan the sky and our antennas listen to the void, the question remains unanswered. Do other civilizations simply not exist? Or were they all filtered out, one by the same inevitable fate that may one day reach us? The mystery of the Great Filter is not merely a scientific theory. It is a mirror of the human condition itself. It forces us to face the possibility that intelligent life may be the rarest phenomenon in the universe, and that our survival, as improbable as it seems, is a singular and precious event. The hypothesis of the Great Filter emerged from the attempt to explain something that, even today, defies our logic: the contradiction between the immensity of the cosmos and the absence of any trace of intelligent life beyond Earth. At first, the Fermi Paradox was merely a theoretical provocation. However, as telescopes evolved and astronomy became increasingly precise, the problem grew more unsettling. The more we observed the universe, the clearer it became that we are alone, or at least we seem to be. In the year 1996, physicist Robin Hansen proposed the concept of the Great Filter to try to fill this gap. He suggested that something, at some point, prevents most civilizations from reaching interstellar communication or cosmic colonization. The theory rests on a simple but devastating line of reasoning. If the universe is ancient and abundant, and if life is a natural process under suitable conditions, then advanced civilizations should be common. We should see them everywhere, in radio waves, in light spectra, in traces of stellar engineering. But we see nothing. This absence is what makes the Great Filter so powerful. It explains the silence by assuming that most civilizations never progress far enough to be noticed. In other words, the universe may be filled with life, but almost all of it is extinguished before it can leave a lasting mark. Hansen proposed that the filter might exist at different stages of the evolutionary journey. Perhaps the hardest part is the beginning, the emergence of life itself, something so improbable that it almost never happens. Perhaps the obstacle lies further ahead, in the leap from simple life to complex consciousness. Or worse still, the filter may be ahead of us, at the point where technology gives civilizations the power to annihilate themselves. The beauty and terror of the theory lie in this uncertainty. We do not know where the filter is, but we know it exists. And with every scientific discovery, the mystery seems to draw closer. The hypothesis gained strength when compared to the Drake equation, created by Frank Drake in the year 1961. This equation estimated the number of communicating civilizations in the Milky Way, considering factors such as the rate of star formation, the number of habitable planets, and the probability of life emerging. When astronomers began filling in these variables with real data, exoplanets, habitable zones, organic elements, the results should have pointed to a universe teeming with civilizations. Yet the absence of any contact forced us to accept that among all these stages, there exists a statistical or physical force that reduces almost everything to zero, the great filter. Over time, the concept evolved from a simple hypothesis into a philosophical lens through which humanity began to perceive its own destiny. If the filter is real, it challenges us to survive. It is a reminder that life, no matter how resilient, is fragile before the relentless laws of the cosmos. But it is also a source of hope. If we have come this far, it means we have already overcome countless invisible barriers, and perhaps by understanding the filter, we can learn not to become the next civilization to vanish. Before any form of life could exist, the universe was a battlefield of destructive forces, a vast expanse where energy and matter waged endless wars. The first stars were born amid chaos, exploding into supernovas that hurled heavy elements into interstellar space. This cosmic violence, though essential to create the fundamental building blocks of life, also represented the first great obstacle. Intense radiation, asteroid impacts, and extreme temperature variations made it unlikely for matter to organize itself into something stable and complex. If the great filter has existed since the dawn of time, perhaps it lies here, in the universe's own difficulty in allowing life to begin. Biogenesis, the process that transforms chemistry into biology, requires an improbable balance between energy and stability. Organic molecules must emerge, persist, and replicate in relatively sheltered environments. However, space is anything but welcoming. Cosmic rays, ultraviolet radiation, and gravitational fluctuations destabilize fragile compounds. Even on planets orbiting within the so-called habitable zone, factors such as solar ejections, lack of a magnetic field, and unstable atmospheres can destroy any attempt at life before it has a chance to take root. Thus, the first filter may simply be birth itself, the inability of life to endure the chaos that created it. Some argue that Earth is an unlikely exception, a planet whose combination of size, solar distance, and magnetic protection formed a rare sanctuary. If this is true, then most worlds never even begin. Gas giants, eccentric orbits, and toxic atmospheres are the rule, not the exception. Frozen moons, radioactive deserts, and boiling oceans portray a cosmos that seems to reject complexity. Even when chemical conditions are ideal, geological catastrophes or collisions can reset the evolutionary clock countless times. The universe, in this sense, may be a cradle that destroys its own children before they learn to live. There is also the factor of time. The universe is about 13 billion years old, and the conditions for life only became truly stable long after its formation. This means civilizations could have arisen and vanished in eras so distant that their traces have completely faded. Life may be a spark that flickers and dies quickly in an ocean of entropy. The Great Filter, then, would not be an isolated event but a constant cycle of birth and annihilation, a cosmic repetition that erases every possibility of continuity before it can take hold. When we look into the depths of space, what we see is not only beauty and mystery, but also a testimony to the primordial hostility of the universe. Every star that explodes, every planet that collapses, every field of radiation that sweeps through entire systems is a reminder of how improbable life truly is. And perhaps it is precisely this improbability that explains why the sky remains silent. Life is not only rare, it is a statistical miracle that insists on existing even amid chaos. Even if life manages to overcome the initial cosmic hostility and emerge on some privileged planet, the path toward consciousness is long, uncertain, and full of evolutionary dead ends. For billions of years, Earth was inhabited only by invisible microorganisms, It took countless mutations, coincidences and catastrophes for these primitive forms of life to evolve into something more complex. The leap from a simple cell to a multicellular organism was one of the most improbable transitions in biological history. Many scientists believe that this passage represents one of the critical points of the Great Filter, an event so rare that it may have happened only once in the entire observable universe. Evolution follows no plan. It is blind and indifferent. Most species that appear disappear without leaving lasting descendants. Mass extinctions, climate shifts, and cosmic collisions erase entire lines of biological development. Life, in this sense, is like a fragile flame struggling to stay lit amid endless storms. Every evolutionary leap, from photosynthesis to sexual reproduction, from the nervous system to social intelligence, required precise combinations of time, environment, and luck. The slightest error, the smallest environmental change, and the sequence unravels. Perhaps the Great Filter is, therefore, the very improbability of consciousness emerging from unconscious molecules. Intelligent life depends not only on biology, but also on planetary stability. It requires long-lived oceans, a balanced atmosphere, tectonic activity that recycles nutrients, a magnetic field that blocks radiation, and a star that does not vary drastically in intensity. Any sudden change in one of these factors can halt evolution before it reaches the level of complexity necessary to generate self-awareness. And even if intelligence does arise, there is no guarantee it will lead to technology. On Earth, only one among millions of species has developed the ability to reflect upon the cosmos, the human being. Consciousness, in cosmic terms, may be an anomaly, an evolutionary accident that combines curiosity, creativity, and self-destruction within a single entity. For every planet that harbors simple life, there may be billions where biology has never gone beyond the bacterial level. Thus, the Great Filter could lie in the leap between life and mind, an abyss that most forms of life can never cross. And if this is true, then the silence of the stars is the sound of a universe where consciousness is as rare as it is fleeting. But the hypothesis does not end there. Even after it emerges, intelligence faces the challenge of survival. A nascent civilization must overcome not only its environment, but also itself. Knowledge brings power, and power brings risk. Consciousness becomes, paradoxically, the harbinger of the next filter, the one in which thought itself turns against its possessor. If the universe is silent, perhaps it is not due to a lack of life, but because every mind that ever inhabited it eventually encountered, in one way or another, the limit of its own existence. When life reaches the point where consciousness awakens and begins to transform its surroundings, it enters a delicate and dangerous territory. The power to create and to destroy begins to coexist within the same mind. Humanity is the living proof of this paradox. We are capable of building cities, decoding DNA, sending probes into space, and at the same time, creating weapons capable of annihilating everything we have achieved. This duality is at the core of one of the most feared candidates for the Great Filter: social and technological self-destruction. Intelligence, upon reaching a certain level of complexity, seems inevitably to lead civilizations toward instability, one that can bring about their collapse. Technological power grows faster than the moral and emotional wisdom required to control it. This imbalance can be fatal. Nuclear wars, environmental catastrophes, laboratory-created pandemics, and the uncontrolled use of artificial intelligence are just a few examples of existential risks humanity faces, and that other civilizations may have faced before disappearing. Every new advancement brings with it a new threat. The energy that powers our cities can also destroy them. The network that connects our minds can be used to manipulate, divide, and weaken. The technology that promises freedom can become the instrument of extinction. Scientists call this phenomenon self-inflicted civilizational collapse. It occurs when an intelligent species exhausts its own resources, destroys ecological balance, or creates systems too complex to manage. Human history on a smaller scale already offers countless examples: empires that fell through greed, societies that vanished due to overconsumption or inequality. Now, however, the scale is planetary. For the first time, a civilization holds the power to alter the climate, modify the genome, master atomic energy, and at the same time, place all of it at the service of its own downfall. There is also the possibility of psychological and cultural filters. As technology advances, human contact diminishes, empathy weakens, and the sense of community dissolves. A species that loses its social bond also loses its instinct for collective preservation. Extreme individualism, disinformation, and social fragmentation can destroy a civilization without the need for war or natural disaster. Collapse would not come from the strength of the universe, but from the inner fragility of consciousness itself. If the great filter lies at this stage of the journey, then perhaps the common fate of intelligent civilizations is the same, to vanish by their own hands before reaching the stars. This would explain the silence. Every world that came too close to mastering the cosmos ended up destroying itself before leaving perceptible traces. Perhaps the ruins of past civilizations are scattered among the stars, invisible, reduced to interstellar dust. But there is also hope. Recognizing danger is the first step toward overcoming it. If humanity can balance power and responsibility, we may become the first species to pass through the social filter. This possibility, remote but real, is what keeps us striving, observing, learning, and above all, imagining. For as long as there is consciousness and the will to survive, there remains a path forward. Even if a civilization manages to survive its own impulses of self-destruction, there still remains a barrier that rises before all forms of intelligent life: the insurmountable vastness of space. The distances between stars are so immense that they defy not only technology, but also the very logic of time and energy. The universe is a frozen, dark ocean, where each star is an island isolated by millions of light years of emptiness. Light, with all its immeasurable speed, takes decades, centuries, or millennia to cross small fractions of that abyss. Traveling between stars, in practice, demands overcoming physical laws that may well be absolute. For an advanced civilization, the challenge of interstellar expansion is not merely to build powerful ships, but to confront the limits imposed by thermodynamics, relativity, and the biological fragility of their own bodies. The energy cost of accelerating a spacecraft to the speed of light is astronomical, and, as far as we know, impossible to achieve without annihilating whatever is on board. Even at near light speeds, a journey to the closest star would take years. A single collision with a grain of cosmic dust could release energy comparable to that of a bomb. Space, contrary to the romantic image offered by cinema, is the most lethal environment that exists. Beyond physical barriers, there is the problem of time. Civilizations arise, flourish, and collapse over scales of millennia, while interstellar journeys would require tens of thousands of years. Any society embarking toward the stars would have to become something entirely different before ever arriving at its destination. They would be distant descendants, perhaps unrecognizable. Expansion, therefore, may be unfeasible, not only because of technological limits, but also due to biological and social constraints. The universe seems designed to prevent any species from spreading freely. Some scientists believe that the true filter is not destruction, but cosmic inefficiency. Perhaps the cost of traveling, building, or colonizing is so immense that no civilization, however advanced, would find the effort worthwhile. Instead, they might choose to remain confined within their own systems, harnessing local energy and focusing on internal survival. This would create a universe where each intelligence lives in isolation, surrounded by vast expanses it will never cross. A cosmos of silent islands, separated not by choice, but by impossibility. Still, there remains the dream of megastructures such as Dyson spheres, designed to capture all the energy of a star. If such structures were common, our telescopes should already have detected their infrared signatures, yet so far we have found nothing, which leads to a disturbing conclusion. Either no one has come that far, or those who did vanished before leaving traces. The universe, therefore, may not be empty, only inaccessible. The technological filter is a reminder that the cosmos is not an invitation but a test. It challenges civilizations not only to survive, but to accept their own limits. Humanity, still in its first cosmic steps, has barely left its solar backyard. If we wish to break through this frontier, we will need more than technology. We will need patience, courage, and a vision of the future that transcends centuries. For perhaps the true obstacle is not space, it is time. In the middle of the 20th century, the Russian astronomer Nikolai Kardashev proposed a way to measure the progress of a civilization not by its technology or cultural achievements, but by the amount of energy it is capable of harnessing. This idea, known as the Kardashev scale, became a landmark in astrobiology and in discussions about the future of intelligent species. It suggests that all the progress of a civilization can be assessed by its capacity to dominate and transform energy. According to this classification, there are three major possible stages, and each represents an almost unimaginable leap. A Type 1 civilization would be one capable of using all the energy available on its home planet. It would fully control natural resources, climatic forces and geological processes, converting them into usable energy. It would be a society mastering storms, earthquakes and oceans, channeling the power of its own world to sustain its existence. Humanity is still far from this level. Estimates suggest that we use only a tiny fraction of the total energy that Earth can provide. We are, at best, a Type 0 civilization, still dependent on fossil fuels and limited resources, vulnerable to catastrophes we barely understand. The next step is the Type 2 civilization, which would have achieved the ability to extract energy directly from its star. To describe such a feat, theorists like Freeman Dyson imagined colossal structures orbiting the Sun, the so-called Dyson spheres. This civilization would be capable of converting the light and heat of its star into virtually infinite energy, fueling interplanetary empires and sustaining trillions of beings. However, building such a structure would require resources equivalent to dismantling entire planets and an engineering capacity far beyond anything we know. To this day, no evidence of such structures has been observed, making their existence purely hypothetical, or perhaps a reminder that the Great Filter prevents any species from ever reaching that point. Finally, a Type 3 civilization would represent absolute mastery over the energy of an entire galaxy. It would control the power of billions of stars, reorganize solar systems, and shape space-time itself according to its will. It would be a form of existence as distant from us as we are from bacteria, a cosmic consciousness capable of traveling through eras, transcending biology, and perhaps manipulating the very laws of physics. Yet the paradox remains. If such a civilization is possible, why have we never seen it? Though theoretical, this scale reveals something profound about the Great Filter. Each leap, from Type 0 to Type 1, from Type 1 to Type 2 and so on, is an almost impossible challenge. Perhaps most civilizations never reach the first stage. Perhaps those few that reach the second disappear before touching the third. Or perhaps the universe itself imposes insurmountable limits, preventing any form of life from achieving such supremacy. The dream of Kardashev, therefore, is not merely a measure of power, but a reminder of the fragility of those who dare to dream. Humanity is still at the beginning of this journey, but the scale shows us what is at stake. Either we learn to master our resources wisely, or we will be just another spark extinguished in the cosmic void. Progress is not only a matter of energy, but of balance. And perhaps the true test of the Great Filter is precisely this: to prove that power can exist without destruction. Few ideas in the history of science are as grand and yet as enigmatic as the Dyson sphere. Proposed in the middle of the 20th century by physicist Freeman Dyson, it represents the pinnacle of thought regarding the energetic future of a civilization. Dyson was not referring to a simple spacecraft or space station, but to a colossal structure capable of completely surrounding a star, capturing virtually all its energy. It would be the ultimate step toward becoming a Type 2 civilization, a leap that would transform a species into something close to a cosmic entity, self-sufficient and independent from planetary resources. Yet paradoxically, this very advancement could mark the threshold of collapse, the moment where dream and destruction converge. The idea of the Dyson sphere stems from a simple reasoning. Every civilization, as it grows, needs more energy. In the beginning, it extracts fuels from its planet's crust. Later, it learns to harness the power of wind, tides, and sunlight. But there is a physical limit to this. When a society reaches the point where its planet is no longer sufficient, the only viable source of energy lies within the very star that sustains it. Capturing that energy directly would mean freedom from environmental constraints, but also a rupture in the natural balance between a civilization and its home. It is the moment when life ceases to depend on nature and becomes a geological force, capable of rewriting its own destiny or destroying it. In practice, the Dyson sphere would not be a solid structure, but a swarm of billions of satellites orbiting the star Uns, forming a vast network of energy collectors that would absorb light and convert it into usable power. To external observers, such a star would appear cooler and emit a strong infrared glow, a signature that astronomers from the SETI project have been searching for over decades. If any civilization has ever built such a megastructure, its trace should be detectable. Yet so far the cosmos remains silent, and no convincing evidence has been found. This raises a disturbing question. If the Dyson sphere is theoretically possible, why have we never seen one? There are only two possible answers. Either no one survived long enough to build it, or those who did do not wish to be found. In both cases, the great filter resurfaces. Perhaps the act of manipulating a star's energy is the final step before self-destruction. Perhaps civilizations that reach that level create machines, artificial intelligences, or thermodynamic imbalances that swiftly extinguish them. The same power that liberates also consumes. Some theorists, however, see the Dyson sphere as a symbol of hope. It would prove that the universe allows the ultimate advancement of intelligent life, a model of harmony between technology and survival. A civilization capable of building it would possess infinite energy and limitless time to evolve. It could spread through neighboring systems, create artificial worlds, and perhaps even overcome the great filter itself. That possibility is what keeps the search alive. The hunt for stars with anomalous emissions is, in essence, an attempt to answer the oldest question of all. Are we alone? If we ever detect a Dyson sphere, it would mean the great filter can be surpassed. But if we keep searching and find nothing, perhaps the silence is the final answer, the confirmation that no one ever made it that far. Between the dream of infinite energy and the risk of total destruction, the Dyson sphere stands as a mirror of civilization's fate. The greater the power achieved, the closer one comes to extinction. As our radio telescopes become more sensitive and our electronic eyes reach deeper into the cosmos, an uncomfortable truth repeats itself with every new observation. There is no one answering. The universe, so vast and filled with worlds, remains utterly silent. This phenomenon is known as the Great Silence, and it may represent the most unsettling aspect of the Fermi Paradox. All astronomical evidence indicates that life should be abundant, and yet no voice echoes back. No signal, no transmission, no undeniable trace of another intelligence. Space seems like an immense tomb where civilizations are born, shine for a brief instant, and then vanish without a trace. Since the 20th century, projects such as CT, the search for extraterrestrial intelligence, have been listening to the cosmos in every direction. Giant antennas scattered across different continents capture the background noise of the universe, searching for something that stands out. A pattern, a rhythm, a technological signature. But the result has always been the same: silence. To this day, no unequivocal signal of intelligent origin has been confirmed. Space speaks only in the cold language of stellar pulses and quasar explosions. The absence of communication raises a disturbing question. If the universe is fertile, why is no one speaking? Some scientists believe we may be listening on the wrong frequency. Others suggest that civilizations might use communication technologies we have yet to comprehend, but there is also the darker hypothesis that there is no one left to speak, that every possible voice has been silenced by the same fate. This vision turns the cosmos into a vast graveyard of intentions, a place where progress inevitably leads to extinction. If the great filter is real, it not only explains the silence, it enforces it. Every civilization that faces it is erased from history before it can leave a perceptible echo. Scientists often say that silence is a form of data. It means something. Perhaps the universe is not empty, but cautious. There may be civilizations in hiding, aware that any attempt at contact could attract unimaginable dangers. This hypothesis is called the dark forest, inspired by a metaphor from writer Liu Cixin. The universe as a nocturnal forest where each civilization is a hunter, moving in silence, fearful of revealing its position. The first to make a sound becomes the target. Thus, cosmic silence would be a strategy for survival, not a sign of absence. But there is also a philosophical side to this quiet. The silence may not be a lack of answers, but an answer in itself. It forces us to face the cosmic mirror and question our own insignificance. Perhaps the universe does not need to reply, because it has already given us the question. The void in that sense is proof that we are alive, the only beings, perhaps, capable of perceiving the silence and giving it meaning. While our telescopes remain pointed at the abyss, the mystery endures. Every distant star is a possibility. Every newly discovered planet is a fragment of hope. Yet so far the cosmos remains still, indifferent, and the great filter hovers above us, like an inevitable shadow. In the end, perhaps the universe is not a stage for encounters, but a cemetery of attempts. And we, as we gaze at the stars, are witnesses to the void, among the few consciousnesses capable of understanding how rare it is to exist. Among all possible interpretations of the great filter theory, there is one that sends chills down the spine. The idea that it still lies ahead of us. This means that humanity has not yet passed the critical point that extinguishes most civilizations, and that the silence of the cosmos could be a warning of a fate we have not yet faced. It is a grim but realistic hypothesis. Perhaps we are living in the calm before the storm, the brief moment of clarity that precedes the inevitable collapse. The filter would not be something from the past, but an invisible boundary drawing closer, testing our ability to survive what we ourselves have created. The recent history of humanity reveals troubling symptoms: accelerated climate change, resource depletion, technological warfare, genetic manipulation and artificial intelligence spinning out of control. Each new advance carries within it the seed of destruction. Earth already shows signs of imbalance, and modern civilization depends on fragile, interconnected systems where a chain reaction could trigger global collapse. If the Great Filter is a recurring event in the universe, it may always manifest when a species reaches the power to alter its own planet. At that point, self-destruction ceases to be a hypothesis and becomes a statistical certainty. The danger does not lie only in the weapons we create, but in our inability to control the consequences of our own knowledge. Intelligence, when devoid of collective wisdom, becomes the agent of its own end. The filter could manifest as an irreversible ecological catastrophe, a global cyber war, or even a moral and psychological collapse of society. The line separating progress from extinction is thin, and perhaps every civilization that once looked at the sky as we do now has crossed that line without realizing it. Some thinkers argue that the true filter is the speed of change. Biological evolution took billions of years to produce the human species, but technological revolution transformed the planet in just 2 centuries. Nature has not had time to adapt. This disparity creates a mismatch between what we are and what we can do. And in many cases, what we can do is lethal. Civilizations that evolve too quickly end up destroying the environment that sustains them before achieving balance. It is the same principle that makes a star collapse under its own weight. If the Great Filter lies ahead, then the destiny of humanity depends on the choices we make now. The difference between survival and extinction may lie in our ability to understand our own fragility. The filter does not have to be a sentence. It can be a test. Perhaps the universe is watching, waiting to see whether we will be the first to overcome it. That possibility, remote but real, is what keeps hope alive. For if we manage to cross the filter, we will no longer be just a local civilization. We will become part of cosmic history, the kind that few, perhaps none, have ever managed to write. There is a more optimistic, almost redemptive interpretation within the theory of the Great Filter, the idea that we have already surpassed it. This hypothesis suggests that the filter is not ahead of us but behind, somewhere in the distant past of Earth's history. If true, it would mean that humanity is a cosmic exception, a statistical miracle that crossed all the barriers that destroyed countless worlds before they could flourish. The simple fact that we exist, conscious and capable of reflecting on our own destiny, would itself be proof that we overcame the most improbable of challenges. In this scenario, the silence of the universe would not be an omen, but a monument to the rarity of intelligent life. To understand this perspective, one need only look at Earth's past. Since its birth, our planet has faced cataclysms that could have wiped out any possibility of continuity. Asteroid impacts, global ice ages, colossal eruptions, extreme climate shifts, and 5 mass extinctions. Yet life persisted. Cells survived fire, ice, and the biological vacuum of the ages. They evolved, multiplied, adapted, and eventually became conscious. This chain of survival is so improbable that, according to many scientists, it may never have happened anywhere else. Every step, every mutation, every event was an unlikely victory against entropy. If the great filter lies in the past, it may have been the sum of all these improbabilities. Perhaps biogenesis, the emergence of life from inert matter, was the true filter. Or perhaps the leap from unicellular to multicellular life was the decisive event. Some argue that the very presence of the Moon, born from a cataclysmic collision with the planet Theia, was the crucial factor that stabilized Earth's axis and maintained a steady climate for billions of years. Without it, evolution might never have occurred. If all these conditions are unique, then we are living a cosmic privilege, the outcome of a chain of coincidences so precise they defy probability itself. This vision completely changes the meaning of cosmic silence. If the filter has already been surpassed, it means we are the first, or the only, to have reached the stage of consciousness and technology. In that case, the universe is in its intelligent infancy, and it is up to us to be its first voice. The silence would be the empty space waiting to be filled by human communication, exploration, and the continuation of life beyond Earth. We would then stand at the dawn of a new cosmic era, inaugurating the universe's awakening to itself. Yet even this optimistic view carries weight. To be the first also means to be responsible. We are the only species, as far as we know, capable of giving meaning to the cosmos. That places us before an existential choice: to care for this privilege or to waste it. If the great filter truly lies behind us, then there is no one else to take our place if we fail. The conscious life of the universe depends on our ability to preserve it. That is the true legacy of a species that has survived the impossible. For every planet that harbors life, there may exist billions that never reach that point. They are silent worlds, frozen or scorched, their unstable orbits lost around violent stars. They are places where the chemistry of life began, but never had time to flourish. Perhaps there were oceans, dense atmospheres, and cycles of energy, and for a brief moment, molecules joined, formed chains, and tried to breathe. But soon cosmic fate intervened. A stellar explosion, a gravitational shift, a collision with another celestial body, and everything unraveled. These worlds are the ghosts of the universe, mute witnesses to how fragile existence truly is. Astronomers have already identified thousands of exoplanets, many of them located within habitable zones where temperatures could allow the presence of liquid water. Yet no evidence of life has been found. That does not mean they are empty, only that they may have stopped too soon. They may have gone through primitive stages of biogenesis, or life might have emerged and been annihilated before leaving detectable traces. The cosmos, in this sense, is a vast laboratory of failed experiments. Every shining star is the center of a natural experiment where life, at times, almost happens. These lost worlds reinforce the statistical dimension of the great filter. If most cosmic conditions tend toward failure, then life becomes not only rare but miraculous. The right distance from a star, the planet's chemical composition, the presence of a stabilizing moon, the magnetic field that shields it from radiation, the existence of water and atmosphere. Each of these factors is a piece of an almost impossible puzzle. If just one of them fails, life disappears. And in the universe, failure is the rule. The dead worlds we observe, Mars, Venus, Europa, Titan, are silent reminders of how many paths life tried to take before being interrupted. But perhaps these planets are not just ruins. They may be the foundations of the future. If humanity manages to cross the great filter and develop interstellar technology, these worlds will become the seeds of a new era. What now seems desolate could one day be habitable. Colonizing Mars, warming Venus, awakening oceans on frozen moons. These ideas may seem distant, but they represent the opposite of failure, the will to continue what the universe began but could not finish. Life, then, would be the very antidote to entropy, spreading into the silence that once reigned. The worlds that never came to life teach us something profound. The cosmos is not cruel, only indifferent. Life is what gives meaning to chaos. Every barren planet is a reminder that we occupy a space that could easily not exist. If the universe is a desert, Earth is its oasis, and understanding that rarity is the first step toward preserving it. Because among billions of failed attempts, we are one of the few that succeeded, and perhaps the only one that can still continue. As the Great Filter hypothesis is examined from different perspectives, biological, technological, social, and cosmic, a deeper idea emerges. What if the filter is not an isolated event, but a universal law, a kind of natural principle that acts upon every form of intelligent life, imposing limits on the expansion and longevity of civilizations? Just as gravity and entropy govern the behavior of matter, the Great Filter would be the force that regulates the growth of consciousness in the universe. It would not be an accident, but a cosmic mechanism of balance, a self-regulation of complexity to prevent chaos from becoming irreversible. In this interpretation, the universe would not merely be the stage where life unfolds, but also the judge that decides how far it can go. Civilizations that grow too fast, accumulate too much energy, or drastically modify their environments could trigger fatal thermodynamic imbalances. Destruction, then, would not be punishment, but consequence. The Great Filter would be the natural response to the arrogance of intelligent species, a cycle that prevents any form of life from taking absolute control of the cosmos. In this sense, the filter is not the enemy of life, but the corrector of imbalance. It ensures that the universe remains stable, even at the expense of consciousness. Some physicists speculate that the Great Filter may be linked to the fundamental laws of physics and the universal tendency toward entropy. Complexity consumes energy, and every organized structure tends over time to fall apart. Life and intelligence defy this tendency for a brief moment, but the price of that defiance is collapse. The more complex a civilization becomes, the more energy it needs to sustain itself, until the cost exceeds the equilibrium limit and the system implodes. It is the same principle that governs stars, economies, and ecosystems. The universe, in this sense, punishes excess and rewards balance. If this hypothesis is true, then the Great Filter is inevitable. It would manifest at every scale and across all times, shaping the fate of each civilization. Some would be destroyed by internal wars, others by natural catastrophes, and still others by their inability to manage their own power. The final outcome would always be the same: silence, a cosmos where intelligence emerges, shines for an instant, and fades away, leaving only scattered traces in the dust of galaxies. Life does not vanish because it is weak, but because the universe itself demands simplicity. However, understanding the filter as a universal law also grants wisdom. If destruction arises from imbalance, perhaps survival depends on harmony. Humanity, upon realizing this, may find a way to coexist with the forces of the cosmos instead of opposing them. Living in synchrony with the universe, and not against it, may be the only way to transcend the filter. The true challenge is not to dominate the stars, but to understand the natural rhythm of space and energy. The Great Filter, then, would not be the end, but the final lesson. Every civilization that wishes to endure must learn to respect the limits of the universe itself. What if the silence of the stars is not the result of destruction, but of choice? This hypothesis, as unsettling as it is poetic, suggests that some civilizations may have chosen to erase themselves voluntarily from the observable universe, not out of fear or failure, but out of understanding. Perhaps upon reaching a certain level of consciousness, they realize that infinite expansion is an illusion, and that true balance lies in withdrawal. Instead of consuming stars, colonizing systems, and altering galaxies, they may have chosen stillness, absolute harmony with the cosmos. Invisibility, then, would be the final stage of intelligence. The Great Filter, in this context, would not be an external catastrophe, but a collective philosophical decision. This idea, known among some theorists as the silent civilizations hypothesis, suggests that the absence of signals is not a sign of absence. On the contrary, it may signify the presence of intelligences so advanced that they have chosen to stop emitting any detectable trace. They might exist in modes of reality completely beyond our perception, as purely digital consciousnesses, energy structures integrated into matter, or life forms based on physical principles we do not yet understand. Such civilizations may have abandoned biological matter entirely, merging with the energy around them, dissolving into the very fabric of space-time. Some physicists and philosophers call this technological transcendence, the point where evolution ceases to be biological and becomes existential. Instead of seeking power and domination, these civilizations pursue stability and purpose. Invisibility, in that sense, would be a form of liberation. They would no longer need to communicate or leave traces, having reached a state of consciousness where time, individuality, and space no longer matter. The silence of the universe, then, would be the sound of billions of minds that chose no longer to compete, to grow, or to wage war, only to exist in peace. But there are also darker interpretations. Perhaps invisibility is not voluntary, but the consequence of inevitable isolation. A civilization that achieves technological perfection may become a prisoner of its own system, unable to leave it due to fear, saturation, or lack of purpose. Instead of exploring the cosmos, it might retreat into infinite simulations, self-contained virtual worlds, artificial universes where everything is controlled. From the outside, it would appear extinct, but in truth, it would merely be asleep within its own creation. If this hypothesis is true, then the Great Filter might not be a physical barrier, but a spiritual awakening. Collective consciousness would realize that the pursuit of expansion is futile, and that the true purpose of intelligence is to understand and accept the cosmos itself. Silence, therefore, would be the highest expression of wisdom. Perhaps the universe is not dead, only meditating. And if that is the case, humanity's destiny may follow the same path. We can continue trying to dominate space and energy until we destroy ourselves, or learn in time the value of silence. Perhaps the next stage of evolution is not the conquest of the stars, but the conquest of ourselves. The day humankind understands this may mark the beginning of a new era, not of expansion but of serenity. Of all the versions of the Great Filter, the most personal and urgent one is the one that involves us directly, because ultimately, the filter may be the human being itself. We are the first known species capable of understanding the universe, manipulating matter, and altering the destiny of life. But we are also the first to carry within ourselves all the means of destruction necessary to interrupt our own story. Humanity lives at the tipping point between triumph and collapse. We are simultaneously the greatest example of cosmic intelligence and the proof of how intelligence can be a threat to itself. In recent centuries, we have transformed the planet in ways that no natural force ever could. We have changed the climate, redesigned entire ecosystems, created machines that think, and built networks of information that connect billions of minds. We have mastered the atom and touched space. Yet at the same time, we have opened deep fractures within our own civilization. Wars, inequality, reckless consumption, and environmental imbalance have become symptoms of a species that has gained too much power in too little time. Progress has brought abundance, but also an unprecedented systemic fragility. One mistake, one miscalculated decision, or one technology out of control could unravel everything. Artificial intelligence, for example, represents a new kind of filter. It is the fruit of human genius, but also a force that escapes our full comprehension. Used wisely, it can lead to the cure of diseases, the solution of crises, and the colonization of space. But if misused, it could accelerate our obsolescence and transform civilization into something unrecognizable. The same applies to genetic manipulation, the advance of nanotechnology, the reckless use of energy, and the exploitation of resources. Every step forward is a choice, and every choice can bring us closer to or further from the end. The human filter is not inevitable, but it is in progress. It manifests in our daily decisions, in our governments, in our relationships, and even in our silences. The paradox is that the more power we acquire, the more dependent we become on moral balance and global cooperation. For an intelligent species to cross the Great Filter, it must be more than intelligent. It must be wise. Wisdom is the antidote to extinction. It is the understanding that life is not a competition, but a continuity. If the universe eliminates civilizations that destroy themselves through ego, Perhaps the secret to survival lies in humility. The future will not belong to the strongest or the most technological species, but to those that learn to coexist with their own power. We now stand at our cosmic crossroads. We can follow the path of arrogance, which leads to collapse, or the path of awareness, which leads to transcendence. The great filter does not have to be our end. It can be our rebirth. Every act of empathy, every discovery used for good, every advancement that respects nature is a victory against the filter. The question is no longer whether it exists, but whether we will be able to overcome it. Because perhaps the true test of the universe is not to survive, but to deserve to continue existing. If the great filter is the breaking point that eliminates most civilizations, what happens to the rare few that manage to cross it? This is one of the most speculative and fascinating questions in modern astrobiology. Let us imagine that a civilization survives itself, that it manages to balance technology and ethics, power and wisdom, energy and stability. What would come next? The Lachim post-filter future represents the stage where intelligent life stops fighting against chaos and begins to shape it, becoming a conscious force within the universe itself. It would be the moment when humanity ceases to be merely a planetary civilization and becomes something greater, a cosmic agent, creator, and guardian of existence itself. In this future, the post-filter civilization would have learned to use energy sustainably without destroying its worlds. Hunger, war, and inequality would be memories of an immature past. Artificial intelligence and biotechnology would no longer be threats but natural extensions of consciousness, harmoniously integrated into the flow of life. Humanity would finally become a force of balance rather than destruction. This would mark the beginning of an era of convergence in which biology, technology, and spirituality merge, dissolving the boundaries between what is human and what is machine. The mind would no longer inhabit isolated bodies, but would exist in interconnected networks, capable of perceiving the cosmos as a living organism. Some theorists call this state the cosmic collective mind, a form of existence where the individual and the whole coexist in harmony. Communication would no longer depend on language, but would become instantaneous, symbiotic, and based on shared consciousness. In this scenario, space would no longer be an obstacle but a natural extension of thought. Humanity, or what remains of it, could move among the stars not through ships, but through pure information, transmitted in frequencies of energy and awareness. The physical body, limited and perishable, would be only one of countless possible forms of life expression. Overcoming the great filter would also mean transcending the fear of death. Life would cease to be a struggle against entropy and would become an expression of the cosmic order itself. Post-filter civilizations would no longer seek to dominate the universe, but to understand it. They might even become the architects of physical laws themselves, adjusting the balance between energy and matter, creating new realities, or shaping unknown dimensions. It is possible that such civilizations already exist, invisible to our eyes, living in planes that our senses and instruments can never detect. If they do, then the universe is not empty. It is filled with life that has already learned to hide in infinity. But there is something even more poetic in this vision, the idea that the post-filter stage is not merely technological, but a spiritual awakening. The moment when a species realizes it is not the center of the universe, but part of a greater cycle, and that its role is not to dominate, but to preserve. This would be the point where humanity stops seeking meaning outside itself and begins to create it. True immortality would not lie in conquering galaxies, but in understanding the value of the present moment. The post-filter future, then, would be the birth of a new form of universal consciousness, a mind that, when looking at the cosmos, recognizes itself in every star. Despite the vastness of the cosmos, humanity still lives on a microscopic point within an ordinary galaxy, listening to the silence and waiting. This waiting, scientific, philosophical, and emotional, is one of the defining traits of our species. We continue to search for signals, for echoes, for any sign that we are not alone. This search is carried out by telescopes that watch the sky night after night, by giant antennas capturing invisible radio waves, and by probes sent into deep space, carrying messages etched on golden plates, destined for whoever, or whatever, might one day find them. Amid all this waiting arises an inevitable question. Do the other voices truly exist, or are we speaking to ourselves across the abyss? Projects like SETI, Breakthrough Listen, and observatories such as the James Webb Telescope represent humanity's continuous effort to decipher this silence. We search not only for life, but for meaning. We look for traces of civilizations in distant atmospheres, detect gases that could only be produced by living organisms, and observe luminous variations that might indicate alien megastructures. Each signal analyzed is a promise, and even when all turns out to be noise, hope remains, because the absence of a reply does not eliminate the possibility. It only postpones it. The cosmos is far too vast for definitive conclusions, and as long as there are stars, there will be search. The waiting for other voices is, in a way, an extension of our own longing for connection. Since the dawn of time, human beings have looked at the sky and projected onto it their deepest questions. The universe is a mirror in which we see reflected what we are and what we fear to be, fragile, solitary, and transient. Searching for other civilizations is searching for comfort. It is the hope that somewhere out there exists someone who also understands the cold of space and the loneliness of consciousness. Every potential signal is a spark of hope, not only scientific, but existential. But there is a paradox in this search. Perhaps the silence does not mean absence, but prudence. Perhaps we are being observed by intelligences that have chosen not to reveal themselves. Or perhaps time itself is the true abyss between us, civilizations that were born and died millions of years before Earth even existed. On cosmic scales, time is so vast that two civilizations could coexist without ever overlapping. The universe might be full of voices, but from different eras. We are perhaps merely the most recent note in a symphony that once echoed and faded away. Even so, the search continues, because seeking is what defines us. It is the act of listening to the cosmos that makes us part of it. And if one day an answer comes, an undeniable signal, a mathematical sequence, a pattern of light, it will forever change our understanding of existence. But even if that day never arrives, the search will still hold meaning. It unites us as a species, reminds us of our curiosity, and teaches us that silence, at times, is also a form of dialogue. The universe speaks, but it speaks slowly. And perhaps, in the patience of listening, we are learning the language of the infinite. The great filter is not merely a scientific hypothesis, it is a mirror that reflects the mystery of existence itself. It forces us to confront the fact that, despite all the knowledge we have gathered, we still know very little about our place in the universe. The theory at its core questions the fate of civilizations, but also questions the value of life, what it means to exist in a cosmos that seems indifferent to the consciousness observing it. And paradoxically, it is this indifference that makes life so extraordinary. Amid the cold vastness and eternal silence, the mere presence of a thinking being is an act of resistance against cosmic oblivion. When we look at the stars, what we see is not only the distant past of light, but also the possible future of humanity. Each star may be a mirror of what we were, what we could have been, or what we might yet become. The great filter, by confronting us with the fragility of intelligent life, gives us a purpose that transcends fear, to preserve and value what we are. Science in this sense ceases to be merely an instrument of discovery and becomes a gesture of continuity, the attempt to ensure that consciousness, in some form, continues to exist. Perhaps the meaning of existence does not lie in escaping the filter, but in understanding it, in accepting that every form of life sooner or later faces its limit, and that it is precisely this limit that gives meaning to living. The universe is vast, yes, but it is also ephemeral in every detail. Stars are born and die, galaxies dissolve, and even space-time itself seems to move toward final silence. Within this cycle of birth and extinction, life is the only thing that dares to say, "I exist." It is the flame that insists on burning, even while knowing the wind is inevitable. The great filter, therefore, should not be seen as an enemy. It is the reminder that existence is precious precisely because it is fleeting. If all civilizations face extinction, what truly matters is not how long they last, but what they do with the time they have. Humanity can still choose the meaning of its story. We can live as if we were eternal, or as if every moment were a miracle. Between cosmic arrogance and existential humility, perhaps the true path lies in balance, knowing we are small, yet capable of contemplating the infinite. In the end, the great filter is the deepest invitation the universe has ever offered, the invitation to consciousness. It asks us to be worthy of the rarity we represent, to look at the sky not in fear of silence, but in gratitude for being part of it. Because if the universe is a vast void, it is we who fill it with meaning. Life, after all, is the filter the cosmos created to observe itself, and human consciousness is the echo of that observation. As long as we keep asking, "Where is everyone?" the universe will keep answering in its invisible language, "They are here, within you." Amid the cosmic silence and the questions that never end, the great filter leaves us facing an essential truth. We are a civilization that thinks, feels, and searches for meaning in the infinite. We live on a small blue planet orbiting an ordinary star in a galaxy among billions, and yet we have the ability to reflect on the fate of the universe itself. That in itself is a victory over improbability. Perhaps we are the result of a sequence of events so rare that they defy logic, or perhaps we are only a fleeting moment, a spark that shines before the eternal dark. But for as long as we last, every thought, every discovery, and every act of empathy will be a way to resist the void. The great filter is more than a scientific theory. It is a reminder that life is fragile, yet extraordinary, that every civilization has its own time and its own limit, and that the true challenge is not to defeat cosmic death, but to live with purpose within the instant we're given. Survival does not depend only on technology or strength, but on the ability to learn from our own power. The future of humanity will not be defined by the weapons it creates, but by the wisdom with which it chooses not to use them. Not by how much it dominates, but by how much it understands. Intelligence only becomes complete when it recognizes its own finiteness. As we look to the stars and search for other voices, it is important to remember that the universe is already speaking to us, through the wind, through the sound of rain, through the beating of the human heart. The cosmos is not indifferent. It expresses itself in the life that observes it. Perhaps we are the way the universe found to contemplate itself, and consciousness is the most beautiful reflection of that infinite curiosity. If we manage to preserve that flame, then we will have surpassed the filter, not only technologically, but spiritually. So the next time you look at the sky, remember, every point of light is both a question and an answer. Maybe we are alone, maybe not. But as long as there is someone listening, thinking, and dreaming, the universe will never be in complete silence. Now, I want to invite you to pause. Take a deep breath. Think about everything that exists beyond us, and about the privilege of being part of it. And if this topic fascinated you like this video, share it with someone who also looks at the sky in search of answers, and subscribe to the channel. Comment where you're listening from. I want to know how far this curiosity about the universe is reaching. Here every night is a journey between the unknown and the infinite. I'll see you in the next video.